All right, introduction to troubleshooting a motor control system. Where you see these red lines going to these terminals, okay, the machine is in its on state, the machine is on, but your machine's not running. Okay, very common how it presents to you as a technician when you go out there and the operator says it doesn't work. So, but before you get into doing anything with your meter, do a visual check. Make sure that circuit breaker that's right there isn't tripped. Make sure you have your green status light on your power supply, on your master control relay or your safety relay. Make sure you got all your green lights. And 4 is typically what you're going to see, but some have less, some have 3, some have more. But bottom line, if there's an LED in that master control relay, that should be lit. If it's not, tell your operator to start checking safety devices, because if this bottom light is not on, and if there's any of these off, that bottom light won't be on. Don't waste your time with your meter looking at anything else until you check all your door interlocks and safety devices and presence mats and light curtains and all that kind of stuff there. Okay? So, also, the beginning, check to make sure that this e-stop has not been pushed in. Operators will forget that they pushed it. Operators' buddies on their way past their buddy's machine will go over there and hit that just to mess with them when they're going on break and things like that. That happens more often than it should. And the guys won't do it because they didn't press it. So they're like, well, there's nothing wrong with the e-stop. And you go over and go, remember, e-stops take two actions, typically a twisting and a pulling, for that thing to return back to its normal state. So check that. This is before you do anything with your meters. Okay? So if it does, but your operator says, I push my button and nothing happens, you come over, you've checked the e-stop, you've checked your circuit breakers, you've checked your 4 green lights, you checked your power supply, you got your green status light there, you manually push that motor starter in and it turns on and it stays on. That's telling you that you've got your latch right here, okay? But your push button switch is your problem where you want to start your look. You're going to start to see if you have power here at 24 volts. You're going to check and make sure when you, to check a power switch with a meter, you're going to make sure you have 24 volts in the system. You will check across this. When you check across an open circuit or an open set of contacts or an open switch, you should see the 24 volts in your meter because it's open. The path is going through your meter. Have your operator press the button, and when he closes it, if that 24 volts don't go to 0 or close to 0, you got a switch problem. Okay, it's counterintuitive, but when you don't see power, that's because the electricity is taking the path of least resistance. A good switch should have about 0.1, 0.2 ohms resistance. Your meter's got about 30 ohms resistance. Okay, but it should go through that. If it doesn't change state or it changes state just a little bit, you got a switch problem. You could also have bad terminations at either one of those 2 switches or those 2 terminals right there. So that's something for you to look at, okay? That's the basic on a push button switch that your machine doesn't go on, but you can manually push it in. And when you do manually push those contactors in, please use an insulated screwdriver. Don't use your finger. Those things will blow up on occasion. You get a little bit of metal dust depending on the manufacturing process. They can just act up, and your Mr. Squiggy there will look like a hot dog that's been overcooked and just burned open, okay? The next typical presentation is the operator says, I can push this button and the machine comes on, but when I release the button, it stops, okay? Now we have the opposite. Now we need to start looking at it. Remember where I have these red lines, you should have 24 volts. If you press the button and the machine comes on, there is nothing wrong with the circuit going straight across. The overload is okay, the armature is okay, and all of these push button switches are okay. If it wasn't, it wouldn't come on with the push button. Where your problem that you need to start looking at is whatever you're using for this normally open contact that this armature controls, okay? That's where you want to check, do I have my 24 volts here at terminal 13? If you don't, you're going to start backtracking that to where this terminates. Sometimes this will terminate back here at number 3 or number 2. It might go to a terminal rail or something like that, but either way, find out where the source, where you should have 24 volts on that wire. And if you don't, then backtrack it again. But that's the bottom line. You have to have 24 volts here. If you have 24 volts here, when this thing is on, you're going to have 24 volts here because it's passing through. But now what you want to do is You can do a voltage drop check across that with a meter. You're going to check your termination across here. This has to have 24 volts there for you to do this voltage drop check first. But when it's on, when your buddy pushes that, you're going to take on your voltage DC, you're going to go across here to here. And if that is closed, you're going to see nothing. You should see nothing in your meter because the voltage is passing through. If there's not, then you're going to see 24 volts in your meter. Okay. So I'm going to cut this short after this. We're right about 6 minutes, and let you guys chew on that a little bit, and then I'll do another video here at a later date, and we'll get into some more troubleshooting stuff on a simple motor control circuit. Okay. You guys be safe out there.